Okay, we're going to go over the general idea of statistics. And what statistics are kind of finding relationships. And we're going to specifically look at scatter plots to help us with these relationships. Before we can get into any of that, there are a lot of definitions that we need to know. Okay, so in statistics, and I'm sure many of you guys have touched on it in science, we write a hypothesis to try to answer a question. So a hypothesis is a theory or statement that we try to prove either true or false. So we put a question out there, and we want to prove it to be either true or false. We hope to be not inconclusive. We want to prove one or the other. That will give us a definite answer. Okay? So when proving a hypothesis, especially with statistics, a lot of times we have to collect data. And we'll collect data through surveys. Okay? One of the ways we can collect data is collecting it ourselves. So if I'm the researcher and I'm doing all of the collection of the data and I'm doing the experiment, that's called primary data, where I collect all the information. Another way we can get it is secondary data, where we can look at studies or publications or work other people have done and take the data from that and then put it into our experiment. So in that case, I haven't collected the data myself. I've taken data from somebody else. That's called secondary data. Okay? Now, when we're collecting data, we usually collect it from two different sets of groups. Okay? There's a sample, and a sample would be a group of people within a population. Okay? So maybe we're trying to take a sample of all high school students, and because I can't actually go around the entire country interviewing all high school students, I interview most of the students at Neil McNeil and maybe a couple other high schools across the country, and then I make an inference from there. That would be just the sample, okay? And when we're looking for specific samples, sometimes the sample could be very specific. Like I'm looking at all the students at Neil McNeil, but I only interview a small portion of them. A population is when we're looking for an entire group. Okay, so for instance, the population of Canada, we know we usually use that to represent something of a country. Okay, so if we're sampling for an entire population, again, we're trying to find information out about a large, very large group of people. Maybe the population of Canada, or all students in Canada. Okay, including elementary and high school. Okay, those could be populations. A census is a survey sent out to everybody within a population. So sometimes your parents have to answer a census. I think in Canada it's like every 7 years. I might be wrong on that, but they send census out at a normal interval in the country, and they send that survey to pretty much everyone in the country, and it's now illegal to not fill it out. It's pretty hard to enforce, but technically you are lawfully abided. You must fill it out, right, Cameron? Great. So, with that, when we're sampling people, we try to do what's called random sampling. And there's different types of random sampling. Okay? What does the word random mean? Not chosen is pretty much a good way of doing it. It's picking things without a specific person in mind. We're just choosing anything out of a group, right? So when we're talking about random sampling, there's a couple different types of random sampling we talk about. One of them is called simple random sampling, where we just choose a specific number of people from a population and we interview them. So maybe I want to interview everybody going into no frills, okay? But I'm unable to actually sit there and interview every single person. It's physically impossible for me. So I decide on Saturday I'm just going to try to interview everybody I can. And then I'm going to make an inference about all people going into no frills. Even though Monday through Sunday I didn't interview any other people, I only focused on Saturday. This would be a simple random sample, just choosing the random people on a specific day. Okay? Systematic random sample is choosing members of a population at fixed intervals from a randomly selected number. So, systematic would be, I'm going to choose every 7th person who comes into no frills, and I'm going to interview them. Okay? I have no idea if it's going to be a boy, a girl, an adult, a family. I have no idea anything about them, but every seventh person is going to be who I'm going to interview. A stratified random sample, okay, is dividing a population into distinct groups and then choosing the same fractions of members from the group. And all these definitions are right in your textbook, okay? So I'm just saying them out loud, I'm not writing them out. So stratified would be, okay, I'm going to choose to interview 10 women, and then maybe 10 men, whoops, and then I'm going to interview 10 families together. Okay, so I've broken them into groups, and maybe it's the first 10 who come in. Those are going to be my random people, okay? So these are all different ways of random sampling. And what would be non-random sampling? Chosen. So let's say I'm talking about everybody who enters no frills. What would be not random?
Sir, we're choosing...
Good. So, would be like choosing an ethnicity. I'm only going to interview the Filipinos who enter no frills. Or I'm only going to interview people with blonde hair. Okay? This is specific, and we'd be unable to make a general conclusion about everybody entering no frills. We're being very specific with the people we're choosing. Okay? What did I put? So the last thing we needed to talk about here was independent and dependent variables. Now, it says in the name that the dependent variable is dependent on our independent variable. And that can be, when looking at the definitions, difficult to understand. But think of it like when we're studying. The amount of hours we put in studying. So let's say we have the option of hours, and we have the option of your grades. Which of these do you think is the independent variable? Your hours. Yeah, your hours studied is your independent, right? Your grades don't necessarily tell you if you're getting an 80, well, I'm only going to study an hour, unless it's towards the future. But essentially, to get a good grade, the amount of hours you put in probably creates or generates whatever your grade is. So your independent variable is the hours, while your dependent is grades. So we're going to scroll down here, and we had days absent and grades. And it's already written above, but our days absent are our independent variable, okay? And our independent goes on our x-axis. And our grades are dependent on how many days we're at school, so that goes on our y-axis, okay? And I've written them in the backwards color, so I should write it like this. Now, this is some data that we'll say that I collected. So when I go back up here, if I collected the data, is it secondary or primary data? Primary. So we got primary data. Okay. Is this an entire population's data? It's just a sample, right? It was specifically for my class, so we're looking at the days absent for my specific class. It's not a census because I did not send a survey to the entire country's population or the school's population. Okay. That's right. When we take a look at how it was taken, because I didn't write down, we'll just say that I took 10 people from each class and wrote out their absence and their grades, which means I'd have a systematic random sample. And I could have technically used any of these three would be good. Non-random would not be as good. And that says ramble, but it's just a sample. Okay. So, with all that being said, we have our independent dependent. We made our x and y axis. Our days absent went from 1 to 22, so we decided to go up by 3s and encompassed everything. I should get rid of this line here. And our dependent had the lowest value of 38 and the highest of 95. And since everything would be between 38, so roughly 40 and 100, we decided to make a broken line graph and start at 30 and go up by 10 so that we could fit it all in this graph. So we'll plot our points. Okay. First one being 2 and 81. So this is where 2 is and 81 is probably there. 0 and 73. Say about there. 12 and 50. 7 and 63. 7 is probably about here. This is 63. So we're up to this point. We've done these 4. 1 and 77. About there. 22 and 38. There's 22, and this is where maybe 38 would fall. 10 and 44. 10 days. a grade of 44. And finally, 3 and 95, way up there. If we were to put a line of best fit, what direction would it be going? Yeah, it'd be going from the top left to the bottom right. Maybe something like this would be a good line of best fit. Down here, up here, anything within this range is acceptable. Okay. What if I had somebody like this, 18 days absent, grade of 90? That's right, this would be considered an outlier, right? This person is somehow doing very well with showing up not very often in class. We do take the outlier into consideration, but we still continue our pattern. What we say is this is maybe something that's not in our pattern or our relationship, where this is still the line of best fit. Most information will fall somewhere around this line here. I don't know.